Testing a null hypothesis and alternative hypothesis. Understanding hypotheses. Before diving into the testing process, it's essential to grasp the definitions of the two types of hypotheses involved. Null hypothesis, H0. This is a statement that indicates no effect or no difference. It serves as the default position that there is no relationship between variables. Alternative hypothesis, H1 or HA. This hypothesis represents a statement that contradicts the null hypothesis. It suggests that there is an effect or a difference. In hypothesis testing, we aim to determine whether there is enough statistical evidence to reject the null hypothesis in favor of the alternative hypothesis. The hypothesis testing process. Step 1. Formulate the hypothesis. The first step in testing whether a null hypothesis can be rejected against the alternative hypothesis is to clearly state both hypotheses. For example, H0, the mean score of students in a class is equal to 75. H1, the mean score of students in a class is not equal to 75. Step 2. Choose the significance level. The significance level, often denoted as alpha, is the probability of rejecting the null hypothesis when it is, in fact, true. Commonly used significance levels are 0.05, 0.01, and 0.10. A 0.05 significance level indicates that there is a 5% risk of concluding that a difference exists when there is no actual difference. Step 3. Collect data and calculate the test statistics. Once the hypotheses and significance level are established, the next step is to collect data relevant to the hypotheses. Depending on the nature of the data and hypotheses, different statistical tests can be used, such as t-tests, used for comparing the means of two groups. ANOVA, used for comparing means across three or more groups. chi-square tests, used for categorical data to assess how likely it is that an observed distribution is due to chance. The test statistic is calculated based on the collected data. This statistic will help determine whether to reject the null hypothesis. Step 4. Determine the critical value or p-value. The critical value is a threshold that the test statistic must exceed to reject the null hypothesis. Alternatively, the p-value represents the probability of obtaining a test statistic at least as extreme as the one observed, assuming the null hypothesis is true. If the p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we fail to reject the null hypothesis. Step 5. Make a decision. Based on the comparison of the test statistic with the critical value or the p-value with the significance level, a decision is made. Reject H0. If the evidence suggests that the null hypothesis is unlikely, we accept the alternative hypothesis. Fail to reject H0. If the evidence does not provide sufficient grounds to reject the null hypothesis, we maintain the status quo. Testing whether a null hypothesis can be rejected against the alternative hypothesis is a crucial process in statistical analysis. It involves formulating hypotheses, selecting a significance level, collecting data, calculating test statistics, and making informed decisions based on statistical evidence. By understanding this process, learners can enhance their analytical skills and apply hypothesis testing in various fields, including psychology, medicine, and social sciences. Mastering these concepts not only strengthens your statistical knowledge but also equips you with the tools necessary for data-driven decision-making. Additional resources. For those interested in further exploring the topic, consider the following resources.